All right, day 2, we're going to talk about radicals. Radicals, a more common name of the ones that we're going to study, are square roots. But square roots are a type of radicals. So here's again. If I say radical, that's the same thing as square roots, at least for this unit. Or I'll also often say just straight up roots, just abbreviated and such. So square root looks like the old school division sign, except that it has like a little hook on the end of it. That's the square root. So right here, this is the square root of 25. Now some of you might be familiar with square roots, but just in case, what square root means is what number times itself is 25. That's what a square root means. Square root means what number times itself is equal to the number that's on the inside of the radical. So in this case, what number times itself is 25? Well, hopefully you know that it is 5. But I think one important thing that you should know is the first 12 perfect squares. The first 12 perfect squares are the first one, the very first perfect square is 1. 1 is a perfect square. The next perfect square is 4. The next perfect square is 9, 16, 25. Do you think you know the next 3? Go ahead and press pause if you think you know it. Otherwise, stay tuned. The next 3 are 36, 49, and 64. Mr. Smith, why are these perfect squares? These are perfect squares because just like 25, if we do the square root of 25, we get 5. It's a nice, pretty answer. All right. The square root of 9 is 3. What's the square root of 16? 4, 5. Square root of 36 would be 6, 7, 8. Now I'll go ahead and come up with the last ones. We come up with 81, 100. 11 times 11 is 121, or the square root of 121 is 11. And the last one is a gross. A gross is a dozen, or the square root of 144 is 12. So those are the first 12 perfect squares. They are good to know. I think they will help you a lot in this chapter. Now, while those are perfect squares, where it gets tricky is when we're talking about the roots of non-perfect squares. This is where this unit gets fun, the roots of non-perfect squares. For example, the square root of 12. 12 is not a perfect square. 9 is a perfect square, and 16 is a perfect square. So 12 is somewhere between those, but it's not a perfect square. So what we're going to do is we're going to go old school style, and we're going to make a factor tree. What multiplies a 12? Well, some of you thought of 6 and 2. Some of you thought of 3 and 4. I'll tell you what, either way would work. But anyways, 6 breaks down to 3 and 2. Now, when we're doing these factor trees, the only things we're looking at are the ends. So 3, 2, and 2. This 6 doesn't count anymore because we broke it up. Check this out. 3 times 2 is 6 times 2 is 12. We're only looking at these things here. Now, radical land is a very treacherous land. You can't get out by yourself. Many have tried, many have perished. In order to get out of radical land, you need a buddy. So, between 3, 2, and 2, who's got a buddy? Well, 2. There's a pair of 2s. So since there are a pair of 2's, a 2 can come out. 1, 2. Sadly, while they have a buddy, only one of them is going to go and make it out. Moment of silence for our fallen 2. Okay, now this 3 got left behind. 3 did not have a buddy, so he got stuck inside a radical land. So 12 is the same thing as 3 root 2. Now, this is the exact answer. The exact answer is 2 times the square root of 3. Bust out your calculator real quick. Now, my calculator, I'm going to erase this stuff. The square root is right there. Now, if I do the square root of 12, we didn't get 2 root 3. This is an approximate answer. The approximate, I'm going to write that down too. The approximate is about 3.46 or so, rounding to 2 decimal places. Approximately is approximately 3.46. Now, just like we said before, 12 is somewhere between 9 and 16. The square root of 9 is 3. The square root of 16 is 4. So we know it should be somewhere between 3 and 4. Now, root 12 gave this grossness. So what if I put in 2 times, because that's what this means. This means 2 times the square root of 3. Oops. 2 times the square root of 3, you see we get the exact same grossness. So that's one way that you can check your answers to see if you simplify the radical correctly. Just put it in your calculator. Let's do another example. How about the square root of 54? The square root of 54. Now, 54 is somewhere between 49 and 64. What's the square root of 49? 7. Square root of 64 is 8. So this is going to be somewhere between 7 and 8. 7 point something. So we make a factor tree. Go ahead and make your factor tree. What multiplies to 64? We got 9 times 6. And we have 3 times 3. 6 breaks down to 2 times 3. 3 can't break down. 3, 2. That's broken down as far as it can go. So we look at who has a buddy. Well, there's a pair of 3's, and then there's even an extra 3. That guy doesn't have a buddy. Only 2 of them pair up. Remember, only one of them comes out. 3. Now, these guys did not have buddies. So they are both stuck inside a radical land. So since they're both inside a radical land, what do you think we should do with these? We're going to multiply them. This is going to be 3 came out, and 2 times 3 got left behind. And then we're going to simplify this. This is going to be 3 square root of 6. That's going to be our final answer. 3 root 6. Again, if you want to check your answer, square root of 54, 7 point gross. The square root of, excuse me, not square root of, 3 times the square root of 6 is the same gross, except that I got rid of the square root of 54 to show you, but you'll see. Oh my goodness. I'm sorry, y'all. The square root of 54, the 7 point gross. 3 square root of 6 is the same gross. All right, so we know that we're right. So here, I want you to try this one by yourselves. Go ahead and press pause and do the square root of 32. Try this one yourselves. All right. Hopefully try this yourself. You make a factor tree. 32 is 8 times 4. 4 times 2, and 4 breaks down to 2 and 2. This 4 breaks down to 2 and 2. So we're looking at all of our ends. There's a lot of 2's going on there, isn't there? You should have 5 2's. So, pair of 2's, a 2 comes out. Pair of 2's, Another 2 comes out. So what do you think we're going to do with those 2's? We're going to multiply them. 2 times 2, and then this other 2 got left behind. So our final answer here is 4 square root of 2. All right, so simplifying radicals not that bad. You make a factor tree, you need a buddy in order to get out. Now, I'm going to go on to the next page. This next section is called Watch Out! There are some tricky things. For example, the square root of -9. What number times itself will give us a negative number? Well, if you think about it, positive times positive gives us what kind of a number? Positive, right? And even negative times negative.
Brian McNulty, please down.
Even negative times negative is equal to a positive number. Remember, this says what number times itself is -9. Well, anything times itself is always going to be positive. Or more accurately, anything times itself is never negative. So, this is no real solution. If you're trying to take the square root of a negative number, it's going to be no real solution. You can't take the square root of a negative number. Now, in Algebra 2, you'll find out, while it's not real, there might be some other types of answers. That sounds strange, doesn't it? All right. That's not to be confused with a number like this. -5 times the square root of 9. -5 times the square root of 9. Well, what is 9? We make a factor tree, we get 3 and 3, and that's it. So they need a buddy. 3's got a buddy. We already have -5, so it's -5. Now this means times, right? If there's nothing there, that means there's a times there. -5 times a 3 comes out. And it'll be -15. If the negative is outside the radical, that's fine. It's like a negative number times whatever the radical is. But it's only when the negative is inside the radical. All right, still a little bit of time. Let's do one more problem, one more example. How about -4 times the square root of 45. All right, now, this is -4. Remember, if there's nothing there, this means times. Is 45 a perfect square? No, it's not a perfect square. So we got to go and make a factor tree. What multiplies to 45? Well, hopefully you know 9 times 5. 9 times 5. And then 9 breaks down to 3 and 3. So we already have a -4. Bring this -4 down. What can come out of radical land here? Well, we have a pair of 3's. So it's going to be -4 times this 3 that comes out. And then what got left behind? The root 5. So this is going to be the square root of 5. So -4 times 3 is -12 root 5. That's going to be our exact answer. Again, if you need to check yourself, hopefully your calculator works. There we go. So if you put in -4 times the square root 45, you get that grossness. And then we got -12 times the square root of 5. The same grossness. So we know that we're right. So simplifying radicals. Go ahead and start working on worksheet 1, or excuse me, worksheet 2. Smith out!